Hello again. It's still Thursday, June 18th, and this is the third video I'm shooting in the series. And before every video, I want to give this disclaimer in case you're watching them out of sequence. I'm not an electrical engineer. I'm not an electrician. I'm strictly a Google electrician, and I'm working on doing a basement finish, and I'm trying to get a handle on the circuits that we have here. So in the previous two videos, I had showed the service panel and I had showed the junction box to show our two hots with the shared neutral. Now what I'm going to be showing you is measuring the current on the shared neutral, because what we want to find out is whether when I've got current flowing in both of the circuits, whether that current is additive or whether it's the difference. We want to see that it's the difference, because if it's additive, if I've got two 15 amp circuits and the current is additive going to the shared neutral, you could potentially have a situation that if I put enough of a load on both of the circuits, that there could be 30 amps running through a neutral wire that's only rated for 15 amps. And that's a problem, because then the wire would overheat and we could have the insulation melt and we could have a fire on our hands. So I'm going to show you how I'm going to test this here. So what I've got is this multimeter that's able to measure amps, and you can see I've got the setting here on amps. So the first thing I'm going to do is I've got the furnace running right now. I just have the fan turned on so that we've got a load on the furnace line. And so here is this wire here is from the supply. Sorry, I'm trying to do too much at once. This wire here is coming from the supply and this black is coming from the supply. Both of these are hot coming from the circuit breaker, the service panel. There's two separate circuit breakers. So I'm going to put this meter on the supply line, and you can see it's at, the light's not great. It's at about 8 amps right now, okay? Which that's the hot coming in. So what we want to see right now is I'm going to actually just put this on the shared neutral, because right now there's only the one circuit that's live. And so this wire here is the shared neutral going back into the supply line. So if we check the reading on the shared neutral, you can see that right now it's again around 8 amps, not quite. So I'm going to leave this hanging on that shared neutral, and then what I'm going to do is I'm going to come to my switches here in the basement, and there's it's the same circuit, so I'm going to turn on all 4 lights that end up being on that same circuit. So there's a light here in the distance, there's one off in the distance there, and there's another light here. That's the circuit that's on the one that's labeled basement for the circuit breaker. And so what you can see now is on this, I haven't moved this, I've left it hanging here. So we have more current running combined. And what you can see, the reading here is it's down near, just slightly over 7 amps, which is lower than it was when it was just the furnace. So I'm going to turn the lights off, and you're going to see that this current actually goes higher again. So I'm coming back over, I'm turning off both of these switches, and you can see that the lights are out now. So there's actually less current running through the overall circuit, which again, it's the shared neutral that ends up getting the return current. And if you look now, you can see that again, this is almost 8 amps. So the point being is that The shared neutral, when I had just the furnace running on it, had about 8 amps going through that shared neutral. When I drew more current on the other circuit that's powered by the black hot, there's more current running, but the net current on the shared neutral actually went down. It didn't go up. So we can see that the way that this is wired is correct, that you're getting the difference in the current between the two circuits, not the sum. And that's exactly what we want to see.